We are going to discuss the satellite related concept, the orbital velocity of the satellite, escape velocity of the satellite, tangential velocity of the satellite, kinetic energy and potential energy of the satellite. Satellite is a natural or artificial body which is rotating around the Earth. Moon is the natural satellite for the Earth. Insat 1B, 2B are the artificial satellites which are revolving around the Earth. In this topic, we are going to analyze the orbital velocity and time period of the velocity, height with which the velocity is positioned, and potential energy, kinetic energy of the satellites. First, write down the definition of satellite. Satellite is the natural or artificial body describing orbit around the planet under its gravitational attraction. Under the gravitational attraction, due to the gravitation between the planet and the Mars, the artificial or natural body will be rotating. Moon is the natural satellite. Next terminology in this topic is orbital velocity, orbital speed of the satellite. The minimum velocity which is required to put the satellite into the orbit is called orbital velocity of the satellite. That is the minimum velocity required to put the satellite into the orbit is called orbital velocity or speed. Okay, right. Write out the definition for that. Minimum speed required would put the satellites into the given orbits around the Earth. Consider this diagram. The Earth radius is RE. From the Earth, the satellite is positioned with a height h. That h is the distance from the Earth. That distance is measured from the center of the Earth as RE plus h. R small r. Small r is the distance from the center of the Earth. Consider a satellite is revolving in the orbit. Its velocity will be a tangential, like this. The velocity of the satellite will be tangential to the circular path. The orbital speed of the satellite. Orbital speed of the satellite. That is V naught. The formula is capital G M suffix E divided by R root, where G is the gravitational constant. ME is the mass of the Earth. R is the distance at which the satellite is positioned. See, this can be expressed in terms of radius and the height with which the satellite is positioned. The small r is equal to, therefore, Re plus H. Again, this can be modified in terms of acceleration due to gravity. That is, G is equal to, what is the formula to find out G? We have already studied Gm divided by Re square. Therefore, this formula can be modified in terms of G Re G divided by Re plus H. Depends upon the data given, we can select either one of the formulas. Okay. Data enna kudukrangalo adukku third mari and the formula va neenga modify na eduthuko select panna. Another condition in this orbital velocity, suppose if the satellite is positioned close to the surface of the earth, then let us neglect the height. H is equal to 0 comparing to the radius of the earth. When the satellite is that means H is very small and comparing to the radius of the earth. So, all of you listen. In the denominator, if you put H is equal to 0, the above formula becomes what? Re. Tell me. Re G divided by Re. Understand? Therefore, the Re can be written as root Re into root Re. Isn't it? Therefore, it can be written as G or E root. You have to remember this formula. Most of the problem related to this formula in the NEET examination, provided that the H is negligible. So, the orbital velocity of the satellite is depends upon the acceleration due to gravity and the radius of the earth. Both are constant value. Both are constant value. When you substitute the value of G as 9.8, what is the radius of the earth, students? Six point four. Yes. When you take the root for this product, it will be approximately 10 to the power of 3 meter per second. It will be 8 kilometer per second. This is the standard values. You have to remember this orbital speed of the satellite when the satellite is positioned close to the earth. Okay. Next important terminology, time period. Time period of the satellite. What is the time period? It is a time taken by the satellite to revolve around the Earth. Okay. Write down this. How to find out the time period? Listen, all students, all of you listen here. The satellite is revolving around the Earth. The angular speed is the angular displacement divided by time. For one revolution, what is the angular displacement? 360 degree, or in terms of radian, 2 pi. Therefore, angular velocity is angular displacement divided by time. Okay. From this, we can calculate a time period. T is equal to, suppose if you forget this formula, because you have to memorize so many number of formulas. There is a chance of forgetting the formulas. In that condition, we have to derive that formula from the basic formula. Okay, to avoid the confusion. That is why I am deriving this time period as 2 pi divided by omega. 2 pi divided by omega. Do you know the relation between the linear velocity and angular velocity? Linear velocity is the product of angular velocity into radius. Now, substitute omega as V by R. In the numerator, it becomes R. Therefore, the time period 2 pi R divided by omega. V. Already we have the orbital velocity, C, in terms of R. V is equal to root of Gf divided by R. When you substitute that value over here,
B.
2
pi R B.
Divided
by root of G and E divided by R.
Very good. R, இப்படி எழுதலாம் 2 pi R, isn't it? Okay. When a root enter into the when R enters into the root, it becomes R squared. Understand?
Sir.
Already R is there. Here, it becomes R cube divided by Gm. Therefore, the time period 2 pi root of R cube divided by Gm. This formula is also expressed in terms of g, that is acceleration due to gravity. See, in this formula, in the numerator, r is given. R is the distance from the center of the earth to the position at which the satellite is placed. Therefore, the R is equated as RE plus H whole cube divided by G. Yeah. Again, in terms of G, another simplified formula. Suppose if the satellite is launched close to the surface of the Earth, the H is negligible when comparing to the radius of the Earth. Therefore, here also the H is equated to 0. Therefore, 2 pi RE R cube divided by G. R cube becomes R squared into R. Take it outside R squared. It becomes R numerator RE divided by numerator denominator RE. It will get cancelled. Okay. Finally, it becomes. Are you following?
2 pi root of RE by G.
Very good. 2 pi root of RE by G. Very good. Now, the time period also has a fixed value provided the H is negligible. Substitute the value of 2 pi RE and G. All are constant, no? Therefore, the time period of the satellite which is launched close to the Earth is 84. That is a standard value, 84.6 minutes. When you substitute the value of 2 pi RE and G. Have you finished, student?
No, sir. Finish.
Okay. Kindly note some important point about the orbital velocity and the time period. The orbital speed of the satellite is not depends upon the mass of the satellite, but the orbital speed of the satellite is depends upon the mass of the Earth, radius of the Earth. The direction of orbital velocity will be tangential to the orbital path. Next important point related to time period. It is depends upon the height at which it is positioned from the Earth. The larger the height, greater will be the speed, time period. Larger the height, greater will be the time period. ரொம்ப long தூரத்துல நீங்க launch பண்ணீங்கன்னா the time period of the satellite will be greater value. When the satellite is launched close to the Earth, time period will be lesser. Understand?
Sir.
These are the important points related to the orbital velocity and the time period. Next terminology is height of the satellite above the Earth's surface. This is the governing formula to find out the height of the satellite above the Earth's surface. Where T is the time period, R is the radius of the Earth, G is the acceleration due to gravity. Have you finished, students?
Yes, sir. Yes.
Okay. Next, how to find out the kinetic energy of the satellite? This is the formula to find out the kinetic energy. That is the basic formula, general expression of mv squared. Here v is the orbital velocity of the satellite. We know the orbital velocity. What is the formula? Orbital velocity formula? Root of g. Therefore, v naught squared is gm by r. Now substitute here. It becomes gm small m divided by 2r. Suppose if you forgot this formula, you derive the formula from the basic expression. Okay. Next one, potential energy. What is known as potential energy? I have already explained this concept. Potential energy is the energy possessed by the body due to the virtual position. When the satellite is positioned at a particular height from the Earth's surface, it attains the potential energy. Already we have derived the potential energy, gravitational potential energy of the object. The same formula can be used here. What is that? Minus capital G, capital M, small m, divided by
by
R. Isn't it? Okay. It is equal to okay.
yes, sir.
Hmm. Next terminology is total energy. Total energy of the satellite. The total energy is the summation of kinetic energy plus potential energy, because when the satellite is rotating at a particular height from the Earth's surface, it has a two component of energy. One is kinetic energy, another one is potential energy. The kinetic energy is due to the rotation of the satellite around the Earth. That is due to the motion. Potential energy is due to the position of the satellite from the Earth's surface. Therefore, the total energy of the satellite is the summation of kinetic energy plus potential energy. So, to get the formula, you have to add the above two formulas. The potential energy, what is that? Minus kinetic energy.
GMG, capital M.
Yes, yes. Now substitute the value. G, capital M, small m. Then here also the capital M is suffix ME. RE plus H. Oh, here also we have to put this in terms of kinetic energy. Students, note down this radius here, RE plus H. Now G ME M divided by
2 into RE
minus
GME M small m divided by RE plus H.
what will come?
Equal to minus GME
Yes.
M by GME small m by 2 RE plus H.
Yeah. This is the important conclusion. See, all of you listen here. The total energy is minus Gm small m divided by 2 Re plus H. Whereas kinetic energy is plus G Me m divided by 2 into magnitude wise same, but direction wise opposite. Therefore, the kinetic energy of the satellite is equal to what? Total energy. Understand?
Yes, sir.
Yes. Very important conclusion. This is here also, and the total energy can be modified by neglecting the H value as minus G Me small m divided by 2 RU. When H is
0.
Very small comparing to the radius. Total energy is equal to, or kinetic energy is equal to minus TE or E. Understand? And then what about potential energy? All of you listen here. So potential energy can be expressed in terms of total energy. This is the potential energy. This is the potential energy. When you divide this value by 2, it will be a total energy. Understand?
Yes, sir.
Yeah. Therefore, a potential energy is 2 times of the
Total.
yes. Very good. Potential energy 2 times of the total energy, or total energy is half of the potential energy. Okay. But anyway, kinetic energy is equal to total energy. Shall we go to the next concept?
Finish, sir.
The angular momentum is denoted by the letter L. Angular momentum in terms of linear momentum. The product of linear momentum into radius. Momentum, linear momentum is the product of mass into velocity into r. Here the velocity is orbital velocity. Substitute the velocity formula as root of
Gm by R.
Okay.
Gm by R.
isn't it?
Yes, sir.
When m small m enter into the root, it becomes m squared. See the expression. The angular momentum is depends upon in the property mattum. Angular momentum is depends upon the mass of the earth, mass of the satellite, and the radius of the earth. Understand? See this expression. This is a small m. M is nothing but the mass of the satellite. This one, mass of the earth. Understand, student?
Yes, sir.
The angular momentum is depends upon both mass of the satellite and mass of the earth, and also radius of the orbit. Yes. Another very important note is angular momentum is conserved. These are the important terminologies. You have to memorize all the formula. You have to learn all the concepts. It will be very useful to solve the problem. Next, the types of satellite. The types of satellites are geostationary satellite and polar satellite. Geostationary satellite is a satellite which rotates in the direction of rotation of the Earth. It rotates from west to east. Whereas polar satellite is a satellite which rotates around the pole, north to south. Yeah. What is known as geostationary? What does it mean, stationary? When the satellite is launched at the height 36 kilometers from the Earth, the relative velocity of the satellite and the Earth will be equal to 0. Therefore, when you see the satellite from the Earth, it will be a stationary. It will be a same position at all time, because there is no difference of speed or velocity. Understand? Satellite, other rotation speed, எர்த்தோட ஸ்பீடுக்கு ஈக்குவலா இருக்கும். நம்ம எர்த் என்ன ஸ்பீட்ல சுத்துதோ அதே ஸ்பீட்ல தான் என்னது, அப்போ எப்ப பார்த்தாலும் ஒரே இடத்துல இருக்கிறது மாதிரியே இருக்கும். That means there is no relative velocity. Relative velocity of the Earth and the satellite is equal to 0. That is why it is called geostationary satellite. Understand?
Yeah.
For time period, what is the time period of this geostationary satellite? 24 hours. எர்த் எவ்வளவு ஒரு தடவை சுத்தினா எவ்வளவு நேரம் ஆகுது? 24 hours. But time period of geostationary satellite is 24 hours. The height at which the satellite is launched from the surface of the Earth is 36 kilometers approx. The satellite is used for communication purpose, for TV transmission and the telephone signals like that. The communication satellite. This type of satellite is communication satellite. With that, we conclude today. We will solve the problem in the next class. Okay.
Yes, sir.
We finished this. Next class, the only one remaining concept, that is escape velocity. It will take 5 minutes or 10 minutes. After that, we will complete the entire remaining problems. You have to revise all the concepts.
Yes,
When
sir.
you come to the next. Okay. Thank you very much.